Good afternoon, Kenya. How are you doing?
I'm good.
Oh, well, wait. I had to, I had adjusted it already because we were supposed to start today, seeing each other today. So I had adjusted it so that we wouldn't have a virtual meeting. So I had to run back in and make a new meeting so that I could meet today. I hope I did all the others, but if nothing, I'll go back and do that because I had it so that it wouldn't do that. So I'll just leave it alone. Because we were supposed to meet in person on Wednesdays, right?
Yes.
But since they extended it till what, the 7th of February, we're not going to until then. Okay. Should we wait on others or just go for it?
It's up to you.
Okay. Well, it is 2:10, so let's just start. Okay. I said share. Sometimes the screen. Okay, see, that's what I was telling you. I had to go back and do all that. All right, so we were not in the middle of chemical bonding, that's for sure. Okay. Yes, this is where we were. We were doing scientific method, right? We finished that, but we need a little bit more on that. The scientific method right here. Okay, with the scientific method, there are what I call the long-term scientific method terms rather than the short-term, which by that, what I'm saying is the ones that, you have to keep doing rather than just do one thing, which is like a hypothesis and experiment and all of that. Oh, Lordy, what is that? I don't know, but that is so not what I asked for. I asked for a PowerPoint. Okay, open. There we go. That was crazy. It didn't open the PowerPoint. It opened a Word doc. There we go. Okay, so on the scientific method, we're going to look at this slide right here. Okay, so we knew that it was a way of solving problems. So it's very similar to a problem-solving strategy. You always have an observation, you know that, and that is what you see or can measure. Hypothesis is, notice the word educated. That means you have to do a little bit of research on it. An experiment is always designed to test the hypothesis. And it leads to new observations. Those observations, you can either modify your experiment or you can come up with yet another set of experiments to test something else. And so the cycle goes on. And this is what I was talking about. When you do this cycle over and over and over and over and over and over, and other people, other scientists come in the picture, and everybody, other thoughts, all kinds of things have to come in. Then you've got these other words. And this is after many cycles. I mean, many is understatement. This is a lot. We're talking about hundreds, thousands of experiments. And that is known as a theory. And this is known as a scientific theory. A scientific theory is totally different from when you say in regular speaking, I have a theory. No, you cannot have a theory. You have to do all of this before you can actually do a theory in science. So one of the things that you see from a theory, usually you can develop a model. And the test of a model or a theory is if it's got predictive value. Okay. Law, on the other hand, this is a scientific law, is something that you summarize after you observed it so many times. Like, when Newton had that apple hit his head, he figured out that everything falls from, down to the ground. Okay. So when he did that, he realized that there must be a force or something, and he figured it out. And after many observations, he noticed that there was a mathematical relationship that he could apply to it. And that is what the law of gravity came down. Now there's a theory of gravity. That's a different story. Law and theory is totally different. So theories, like I was telling you, they have predictive value. And this is the one thing, if your predictions, because there were a couple of things that were done where the predictions of yesteryear, were wrong on the new things that could be done now. And so the theory had to be modified, changed, not changed completely maybe, but modified. The theory explains why something happens. Remember that. Theory is why. And the law is how. And if you look, theory ends in Y, law ends in W. So if you remember why and how, right? So pay attention. And that is, when you say how, you don't have to explain why. You just say how. It falls, at this speed due to gravity, the end. Why does it fall? Well, that's a different story. And then there's usually an equation, not always, but there could be an equation of how things change. Like for every action, there's equal and opposite reaction, not necessarily a mathematical relationship, because you could be talking about a lot of different things. But, mass equals force times acceleration, that is a mathematical equation. So that's the second law of motion. Third law of motion is the one where you have them equal and opposite reaction. And the first law just says that inertia, right? That's known as inertia. It says that something will move unless something stops it, and keep on moving unless something stops it. And usually you can attribute the something to being like a friction or something like that. Okay, that is the scientific method that we have. So this is a diagram where you have your observations, which lead to your hypotheses. Then when you have your hypothesis, then it goes to an experiment. The experiment gives you results. Those results might lead you to change your observations, your hypothesis, and your experiment again. Once you've done all of that, you can discover a law. That's just a pattern that goes on. And it can lead to an explanation of why this happens. That's your theory. That theory has predictive value. Like I said, you can make predictions with it. Like, this is how they predict the weather. They had a lot of observations, they did experiments, they had hypotheses, they tested them, and it slowly modified it. And putting it all together, they made a model. And that model can predict the weather pretty good. I mean, not always, right? But it does have predictive value. And the chances are that most of the time it does predict it. There are things in the weather that can change. And since things change there, you don't have to actually change the theory itself or your model. You just have to add the new parameters to that theory so that it actually responds correctly. And like I said, weather changes very easily, very quickly. So long-term predictions are almost impossible. But there's an experiment again. So see, once again, you go back up, you modify it if there's something that didn't work, and then you go back on it. And that's how it works. This is the whole entire scientific method in a nutshell. All right, so when you have a difference between law, like I was telling you, and theory, just remember those two. I used to do an assignment to do, I ask them to research the law of gravity and then the theory of gravity, because they both exist. And if you do that, you notice the theory of gravity is different. And if you read it, then let's not do Wikipedia, because that is so not. Now, see, this is the law right here. You see that? That's all it needs. You don't even need to know anything else about it. This is all you need. You don't know why it happens. You just need to know this is what happens. But why does it happen? That's what we want to know. And that you would go to, like, see, there's law. You don't want law. We want the theory. Okay, you know, it's based on an assumed force acting between all pairs of bodies. When a mass moves, the force acting on other masses has been considered to adjust instantaneously to the new location of the displaced mass. But that is inconsistent with special relativity. And so there are things that you can look at, but if you just summarize it right here, one body produces a gravitational field that permeates all surrounding space, but has weaker strength farther from its source. That's true. If you're not as close, things don't get as easily attracted. And then the next one is the Newtonian force of reaction is viewed as a response of the first body to the gravitational field produced by the second body. There being on all points in space a superposition of gravitational fields due to all bodies in it. So that is what the gravitational theory. See, it's totally different from the other one, which is the law. Oops, sorry, the law. Okay, so that's one of the things that I was telling you. You just got to watch that. You have to always look at the difference. Nope, that's not what I want. Okay, I have to go back to modules. Excuse me. All right, so here, I passed it as always. Okay, so once we have looked at that, we have this thing that I think I told you about, how to do the atomic theory scientist. And some of you, and it is due already. These were due, but I don't see anybody submitting it. Let me see. Speed grader. Let me see if I got people. Yeah, I do have some people that submitted it. Okay, that's good. All right, so that's what I wanted to know, is make sure that it was on there. Okay. So you've done that. Okay, so after the scientific method, we are supposed to look at the metric system. There's one thing I am going to go over in that same PowerPoint that we had up, and that is this one. One of the things we didn't actually go over is how do you deal with something that is a complex significant figure. So if it uses both addition and multiplication rules, what you do, I kind of did go over it, but I didn't go over an example. It's you round once you change the rules. In other words, if you're using addition, 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 you're good. Don't round until the end. But if you're doing addition and then multiplication, you round after you add, and then you round after you multiply. So right here, for example, this is 9.23 times 8.4, minus 8.4 divided by 1.82, but it's times this. Okay, so I don't know if you remember the order of operation, how it goes. So first thing you do is you need to subtract. When you subtract, right, you end up with this number here. Oh, sorry, did not do it yet. Hold on. This does not have answers. Okay, so we need to do this one. Where is my, I have to find my calculator. Hold on. There you are. Okay, I just had it under something. All right, so when you are doing this particular one, you got 9.23 minus 8.4, and that's going to give you 0.83. And remember, you round when you are done. So 0.8, right? Because 0.83 would be too many decimals since we only have one decimal on that one. So that would be 0.8. And then you would do the division, right? And that's going to give you whatever it gives you is fine, because we don't need to round yet, because the division and multiplication are both one and the same. All right, so whatever it gives you, then you multiply it times 4.53, and that's going to give you 1.997. Now, looking at sig figs, you know that your answer is going to be 1.99, and when you round it, it's going to give you 2.00. So that's the answer, is 2.00. The other one, you know, is you multiplying it first and then adding. So just like that in your calculator would be good, because you first got to multiply. But the thing with this is you multiply it, that's good. You round it, you multiply it, you round it, and then you add, and then you round it again. So that's two roundings that you need to do before you add. Okay, so let's do that. So it's 2.5 plus 1.8. That gives you 4.3. So that's the first one. And that's a good one because, not 4 plus, sorry, clear, times. I don't know what I'm doing. 2.5 times 1.8. I hit the wrong thing. I was like, that's wrong. Yeah, that is 4.3. So I did do, okay, never mind. 2.5 times 1.8 is 4.3. And then plus, we're gonna do the next one, which is 3.3 times 2.7 first. And that gives me 8.91. You notice that 8.91 has to be rounded to 8.9, right? Because those are only two sig figs. Now when we add, we're going to get 8.9 plus 4.3. That's going to give us 13.2. And that is unacceptable also because you cannot accept that answer because we only have 2 sig figs. So the answer is 13. You see how that worked? Yes? Did I confuse you enough? Actually, no, that is 13.2. Never mind. I'm confusing myself. I was doing multiplication in my brain. Okay, so basically, if we are going to show you what this looks like, it would look like this. You would have to do this, right? And then round it. And that ended up being 0.8. Because we got to watch the 1 decimal that's on there. Okay. Then you divide it by 1.882. You don't have to round here because you still got one more, right? Now, once you hit that end, I got 1.997. Okay, so 1.997. We can only have officially just one sig fig, correct? So the answer is 2. Not even 2.0, just 2. 2, period. All right, on the other one, when we did the 2 roundings, we multiplied the first one, we got 4.3. We multiplied the second one, we got 8.91 or 92, whatever it was, but we need to round it to 8.9 because there's only 2 sig figs, right? 2 sig figs in both. Okay, so once we add these two, now that's the next step. We add those and we get 13.2, and that is okay because it doesn't matter that it has 2 sig figs. What matters, since it's an addition, is how many decimals, and we only have 1. That's what I was saying. Okay, so let's clear that, and that's how it works. Sorry, sometimes I even confuse myself when I'm thinking about this, but that is correct. That is all it is. All right, so that being said, let's go back to, you won't let me escape you. Why won't you let me escape? I do not want you anymore. Ah, here we go. All right, so after that, we want to look at the next thing is metric system and uncertainty and measurement. And so this is our next one right here. We're going to look at this PowerPoint. Hopefully we can go here. And this is the same thing. And I want you to see that we have okay. Sorry, that's my phone ringing. It's always ringing. Okay. All right, so we did this already. Next part that we're doing is this coming up, which is our types of error. Okay, you know that when you measure, you have to have a unit. So when you are measuring, you have to have 2 parts, the number and the unit or scale. Because if I just say something measures 2, you would be going to what, right? What if I say 2 feet? Then you know. If I say 2 meters, then you know. If I say 2 grams, then you know. Otherwise, I'm just saying 2. 2 is a number. It's not a quantity. Okay. And we use, for these kinds of measurements, we use the system, SI system, or actually known as Le Système International, which is based on the metric system. And it's a prefix plus a base unit. So how does that work? Okay, you have the prefix, which tells you the power of 10 that you multiply by. And this is a very easy conversion. And your base units in the metric system are the following. For mass is the kilogram. Remember that. Everything else doesn't have a prefix, but mass does. For length is the meter. You notice this is not kilometer or millimeter or anything like that. It's just the meter. The time, obviously, is second, and second is abbreviated S, not SEC. The temperature is Kelvin, and it's not degrees Kelvin, it's just Kelvin. Electric current, which we won't look at, is the amp or the ampere. The amount of substance, and that is a unique to chemistry unit, it's the mole. Okay. So those are your base units. Now these are some of the prefixes and what they mean. Okay, so you got giga, which is a huge number. It's 10 to the 9th. So you got 9 zeros. Mega is 10 to the 6th, so you have 6 zeros. Kilo, 10 to the 3rd, or 1,000. Deci is 0.1, or negative 10 to the negative 1. Centi, 10 to negative 2, negative 3, negative 6, and negative 9 for nano. So you can see all of those. So there are all, not all of them here. However, we are going to use some of these. And I have another thing that I'm going to give you. Now for volume, okay, so these are what is known as simple units. They don't come from anywhere else. They're just units. These are known as derived units because they are either multiplied or divided, either multiplied by another unit or divided by another unit. So gram is the mass of 1 cubic centimeter, and the liter is defined as the volume of 1 decimeter. Now, 1 centimeter cube is also equal to 1 milliliter. Okay, remember that. So 1 centimeter cube and 1 milliliter are one and the same. Mass is the measure of the resistance to a change in motion. That's one definition of mass. Mass is also the amount of substance or the amount of matter contained in anything. Weight, on the other side, is the force of gravity. A lot of people get those two confused, mass and weight. Now, if you were an astronaut, right, and you went to the moon, your weight would change, but the mass would remain the same. And they are sometimes used interchangeably, yes, like on Earth. On Earth is pretty much the same because our gravitational pull is what we're looking at. And remember, mass can change, but weight can. Now, what are we talking about uncertainty? Uncertainty is why we use significant figures. We've already done this, but we're talking about it again just so that we tie it into what's next. And all measurements are uncertain to some degree. It all depends on the instrument that you're using to measure things. The word that we need, and it's new, is called precision. It's how repeatable it is. Remember that. Precision is how repeatable or how close the measurements are to each other. Okay? And accuracy is how correct, how close that measurement is to the actual or true value. So these things can lead to error. And you have two types of error. Random error, which is random and it happens because of whatever. There's no real reason. And there is an equal chance of it being either high or low. And it's usually addressed by averaging the measurements. That's why whenever you're doing any kind of experiment, you want to do it 2, 3, 4, 5, 6 times, just depending on how good your results are, depending on what you want too. All right. Usually 3 is the minimum, because if you have one that's an outlier, at least you have 2 others that you can average. But if you have 2 measurements and one of them is an outlier, how do you know which one's the outlier if there's no other one that you can look at and say, oh, it's closer to this one than to that one? Yeah, you can't. So you usually have to have a lot of them. All right. And the last error is known as systematic error. Systematic error happens due to some reason, and it usually ends up being in the same direction, either too high or too low. And you do want to avoid it because it is something that you can control. Usually it's due to bad equipment or bad technique. You can fix bad technique, you can fix bad equipment, right? But you cannot fix random things. You just can't. So a better precision usually implies better accuracy. Not always. You can have precision without accuracy, but you can't have accuracy without precision. It says here, unless you're really lucky. And we're going to look at some stuff right now. All right, so looking at that, we're going to stop here and we're going to leave it. We're not looking at the metric system yet. We're going to look at error. And for that, we need to go back to this and look at the different types of error and how to measure it. Well, accuracy and precision, sorry, and how to measure it. Okay, so right here, we have this PowerPoint known as accuracy and precision. And I'd rather start with this one because the scientific method is pretty easy, but this is easier, I think. So accuracy and precision. This is another PowerPoint, so I'm going to download it now. Here we go. We're going to open it. All right. So whenever you're looking at this diagram, you notice that precision says increases from bottom to top and accuracy from left to right. So that means that the most precise would be C and D, right? And the most accurate would be D and B, okay? So if you're looking at precision, look at what C and D have in common. They are all close to each other, right? Doesn't matter if they're not exactly in the middle, because that's not what we're looking at. We're looking at precision of measurement. Your measurements are precise here and they're precise here. Are they accurate? No. See, this is accuracy. These are neither one of these two are accurate, but these two are. Okay, so this is a precise and accurate. And this is a accurate, but not precise, because they're still spread out, you see? Okay. We're looking at the definitions. What is the difference? Well, accuracy is how closely a measurement matches the true or actual value. They're going to give you that normally. To be accurate, you only require 2 measurements: the true value, right? The one that they give you, and the one measurement that you took. And to calculate accuracy, you use this formula right here. It's known as percent error. Percent error is equal to the experimental value. That's the one they get that you get yourself, minus the actual value. That's the one they give you, divided by the actual value times 100. So you actually have to do this math first, then that, and then this, right? And multiply. Then, like I said, subtract, divide, then multiply, which is what we did in that last one that sig fig example that was complex. All right. So let's look at this one. Is this accurate or precise? Remember, precise, right? Because precision means how reproducible it is or how closely they are to each other. It requires more than one measurement because they got to be close to something. And it has nothing to do with the true value. You notice how far away they are from the true value. None of the values are close to the target, but they are close together. So to calculate the precision of a set of measurements, we need to use this formula, which is known as percent difference. In order to do that, you take the highest value of the values that you have, subtract the lowest value from it, divide it by the average value, and multiply it times 100. You might want to write down these two formulas. So I'm going to bring you back to this one. Okay, so write that formula down, put accuracy above it. Might want to write down, you might not want to. I always say might, but I'm telling you to. Write down what accuracy is and how you figure it out, okay? And write down your percent error formula. Or you can take a picture of this and then write it down later. All right, the next one is precision, right? Write down that and write down that formula. Write down what precision means and what the formula is. Okay, once you've done that, we proceed. Now let's see a little bit about precision and accuracy. And you guys can answer this on the chat. Accurate or precise? Let me move the chat over so I can see. Okay, so you have 1, 2, or 3. Which one is it? Okay, very good. Yep, it is correct. It is 2, precision. Next one. There you go. All right, this one. 1, 2, or 3. Okay, you said 1. Both of you said 1. Remember what precision is? It's both, right? Because they're both in the right place and they're close together. So that's why it's both. All right, let's do the next one. Okay, and it explains to you why, and I just did, so I'm not going to read that. Okay, now we have target measurements. Let's look at what it says. Okay, on here it tells you very clearly that. Okay, hold on, I gotta move this over. Okay, so a sample is known to weigh 3.182 grams. this girl waited 5 times, and this is the resulting data. It's terrible. Which measurement is the most accurate of the 5, right? So is it 1, 2, 3, 4, or 5? No, nobody's saying anything. It's a little different when you have numbers. One, 2, 3, 4, or 5. Which one? Okay, since you're not answering, here goes. It's 2, of course. It's the closest to 3.182, right? All right, now, this one is telling you, look at the data. Look at the length of the object that is known to be 14.5. Which student had the most precise work, A, B, or C? Okay, let's look. You have a table, you have the trials, there's 5 trials per student. Which one was most precise? Okay, student C, you say. Okay, let's see. Okay, what does precision mean once again? Precision means how repeatable it is. Has nothing to do with how accurate, right? It has to do with how close their own measurements are. And if you look at student A, even though their numbers are off, they're close to each other. They're only 0.1%, right? 0.1% from each other. Okay, now the next question, same data. Now it's asking you which one is the most accurate, A, B, or C? This time you're right. Yes, that is correct. This is the right one because now we're looking at the actual number, which is 14.5. And the closest ones to that are student C's. They're very close to it. It's actually pretty accurate. Okay. And there's your answers. Okay, now out of these guys, it's just explaining to you that in order to win this archery tournament, the archer must hit the target the most times. The winner must be accurate and precise, right? And in order to look at them, you look at the first archer, it's just precision. They hit the same area, the target every time, but not the right place. The second archer was accurate because he hit the target once. And the third one was accurate and precise, both, because not only did she hit the target every time, but she also, or she or he also hit it consistently, right? All right, so basically they're all repeatable. As a matter of fact, they're so repeatable, they fell in each other. He split the arrow. All right, so that's kind of how that works. All right, so we're going to stop here and we will resume metric conversions next time. And that's basically it, ladies. I will see you Friday and we'll continue then. And I will go ahead and mark you present. And that is it. You have a wonderful rest of the day.